Hello everybody, welcome to exercise 5 on page 42 of the workbook. Let's take a minute to read this exercise together. So they're giving us a function f of x equals x squared plus 4 over x. We've got a graph of it over here to the right. And they'd like us to sketch in tangent lines to f of x at x equals 1, 2, and 3, and then to calculate their slopes. All right, so why don't we start by drawing in those tangent lines. So at x equals 1, we'd be sitting here. We draw in our best approximation of a tangent line. It looks like that. And then same thing at 2 and 3. So those lines would look, roughly speaking, like that and that. Okay, and it's our job to actually calculate the slopes of those lines that we just drew in. Okay, how do you find the slope of a tangent line? Well, we've talked about this before. The slope of the tangent line is the derivative. So we need to calculate the derivative of the function that we were given up here. Okay, and to make it easier to do that, we might first rewrite this function. So x squared, that's something that we can take the derivative of just using the power rule, but what about this 4 over x? Okay, that's a quotient. We don't have a formula that addresses that situation, so we'll use the algebraic technique that we used before. We'll rewrite that as 4x to the negative 1. We're taking that x in the denominator and just moving it into the numerator, changing the sign on the exponent. Okay, so to take the derivative, we just need to use the power rule a couple of times. So starting with the x squared term, if you take its derivative, you're going to get 2x to the first. So bring the power down, decrease the exponent by 1. Okay, and then 4 as a constant, we'll pull it to the side. And we're ready to take the derivative of x to the negative 1. That's also a power rule. So we'll bring the negative 1 down and decrease the power by 1. What happens if you subtract 1 from negative 1? You get negative 2. So negative 1x to the negative 2 would be our derivative there. Okay, and let's simplify that. So 2x to the first is just 2x, and then we've got a minus 4x to the negative 2. Okay, there's our derivative. Okay, so to find the slopes of these three lines, we just need to substitute these three x values in one at a time. Let's start with x equals 1. Okay, so f prime of 1 is going to be, we'll take our formula that we just found and substitute 1 in for all of our x's. Okay, you can do that calculation and confirm. You're just going to get 2 minus 4, which is negative 2. And that should be the slope of the tangent line at x equals 1. Okay, so that's telling us then that the very first line that we drew should have a slope of negative 2. What do you think about that number? Does that look plausible? You can see from the picture that the slope of that line is negative, so at least that's an indication that our answer might make some sense here. Okay, and then f prime of 2, same idea. We're just going to substitute 2 into our derivative formula for our x's. So we'll get 2 times 2 minus 4 times 2 to the negative 2. Okay, and if you do the arithmetic there, let's see, that's going to be 4 minus 4 over 4. I'm thinking of 2 to the negative 2 as being 1 over 2 squared. Okay, and this time you're going to get 3. Okay, and that tells us that the slope of the next tangent line should be 3. And notice that also agrees with our picture in the sense that we can see that that tangent line has a positive slope. Okay, and then finally f prime of 3. Same idea. We'll take 3 and substitute in for our x values. Okay, and you can do the arithmetic there and come up with, I'm going to round that off to a decimal. Okay, that's not quite as nice a number, 5.55 about. Okay, and that tells us what the slope of that third line is, 5.55. Okay, let me go ahead and just circle our 3 numerical answers. That's what they were actually asking us for, and we are done.